Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, so I think this session we need to test a bit. What is this? Inline 10 array works for all builds. Min. Okay, fair enough. Can we get... Okay. Instead, can we get min into this file? Can I get min? What do we need to do to get min? The new code is harder to read. Labels. Compile. Minor. Remove dependency. Okay. Two fails. Well, that's not good. Why? That has worked. Okay, so we need to test now generals and take a good look at the particles. Yeah. G generals. In the meantime, let's also look at this one here again. What do we need to set this in the first place? It is not used afterwards. See, it's to make sure that the next random sound to play is not the same as the previous one. Yeah. Yeah, I was looking at this previous session. And yeah, the question is, how do we How do we deal with this? This is not great. This one is also const, right? Jesus. Yeah, it's also const. Command X slots. Command X slots. Yeah. It's a playing audio index. Okay, let's think about this. So we could make this function const, yeah. But that also sounds weird because we are modifying this thing, right? So it's not great. Yeah. Add audio event. How about we say get playing audio index? Okay, I have some idea what we could maybe do. Maybe we add like a mutable struct in here. There already is a mutable thing in here. Mutable can be modified even on const objects. Audio event info. Event info. Yeah, so I would say we move this one into a mutable, like this guy, And then here we allow this to be modified in context. So we can here get audio event info, set audio event info. Okay, how is this one used? It's just a pointer we set. Okay, yeah. Yeah, I would say we use mutable. Good. But before we do that, let's review the particle effects here. So we see the smoke, we see a rocket boogie, missiles, explosion effects, lens flares. Yeah. Everything is there. Then let's launch a China mission, yeah. On hard, yeah. There they are, the Chinese rolling in with the tanks. Some beautiful confetti particle effects. Delicious. It looks like snow, but it is confetti. And he's going in there. Going in for the kill. Oof, Lotus got a big hit there. Oof. Beautiful. I mean, not the death, but the particle effect, of course. No. No. Big destruction. Everything has been killed. Okay, let's take the forces here. Let's rush. Dragon tanks, they're holding up the red guards here. so slow. Oh my god, what is a pathfinding doing there? The dragon tanks take a turn. There's a big shootout here. Okay, let's rush. Oh, we got the Battlemaster friends. Okay, very effective rush so far. Mm-hmm. Mm-hmm. Oh, there's one injured guy that holds up the company. Oh, reinforcements are rolling in. Very dangerous. Very slow walking. They're killing the environment, but the friends are coming. Yeah, the MiG jets. Yeah, beautiful. Very nice. Everything dies and the forest burns. Very nice. Okay, let's put the injured guy here into the house. He deserves a rest. Yeah. In the meantime, let's burn a bit the forest here. It's actually really cool that it can burn the trees. Wow, the chain reaction is still going on here. Doesn't stop. Okay. Oh, it's big destruction here. Okay, but the particle effects look pretty good. Yeah. Yeah. Mm-hmm. 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 Oh, I cannot click this guy here. That was weird. That was extremely weird. Huh. Huh. Okay, well, the good old dragon tanks are upgrading. I think we lost the dragon tank, didn't we? Mm-hmm. Mm-hmm. Well, as far as I can tell, the particle effects are looking very solid here. Yeah. Nuclear explosion. And we are victorious. That's most important. Why did they choose the mountains for the victorious screen? Okay, that was a good test. Hong Kong, China, Hong Kong crisis. Mm-hmm. There's a bomb on the bridge. Uh-oh. Uh-oh. Sabotage. Uh-oh. Oh. Brutal. Uh-oh. I've never seen this cutscene before. It's really amazingly made. Wow. Cool. There was only the dozer survived and a few troops. And they despawned before the cutscene ended. Oh, look at this beautiful house here. It's so high res. Okay. Well, we have dozers. So I guess we put the soldiers there into the house. We have one tank to protect our base. There's a UN crate here. There's not much room here. Okay, I don't want to play though here. Not forever. Maybe we kill some buildings here. Let's kill here one of the houses. So particle effect looks good. Yeah. Uh-huh. Oh, that takes forever. Okay. Man, this tank takes forever. Finally. Okay. Yeah, I as far as I can tell, particles work. We're good. Yeah. Yeah, good. All right. Then with that in place, let's go to main branch. Good. So what I would like to do here for this one, I think it's a bad idea to do this here. We're removing the const here. What we do is we make this setting immutable. So set audio event info. Good, then we make this const, and then mutable. This one is also mutable. Then this one we make mutable. So playing audio index mutable. Mutable. This one needs to be const. Mutable. Get. Set. Is mutable. Okay, and then we simply remove this here. Yeah, that should do. And then we say this seems really hacky, and Mark L admits that it is. We do this so that we can randomly pick a different sound the next time. Yeah, I would say we do that. Let's see if it compiles. Refactor. Audio events. Mutable index. Refactor. Audio. Audio events. Remove. Remove constcast. Constcasts for. Okay, while we wait for this, let's take a look at this guy here. Supplemental preliminary change to that and modifies JIT behavior so that offensive commands such as attack and guard are deferred when parked with no ammo. This aligns the behavior a bit more with the in-flight logic in which commands command behavior is dependent on whether the jet has ammo. Change essentially expands the command deferral window until the jet has reloaded at least one shot. Raptor with no ammo defers its attack until it is fully reloaded. Defer MT1. Demonstration 2. Attack and guard commands are deferred with no ammo, but immediately performed when partially reloaded. Attack and guard. Okay, I'm surprised about this inconsistency here. Here it claims this, and then here it claims that it will perform it when it's partially reloaded, and here it will wait until it is fully reloaded. Why is there this discrepancy? Huh? Deferred with no ammo. Parked. Defer until fully reloaded. Parked. No ammo. Attack and guard are deferred when parked with no ammo. This aligns the behavior a bit more with the in-flight logic in which command behavior is dependent. Hmm. Hmm. Okay, so this one has failed, yeah. Let's open Simei GUI. RTS. Good, then this is done. Let's push it. This change removes cons casts for calling. Factor gen stage minor. This change is an alternative to it removes. I created an alternative change that is less intrusive. An alternative change proposal for this that is less intrusive. be less intrusive. Edit. Closes. Okay, so there's that. Okay, let me take a look at this here. Enhance overall performance of game server. What is this? What? Copilot AI assign Copilot to Tintin Hammonds. Initial plan. What is this? No changes to show. What is this? What? Oh, that didn't go well. Okay, good. Let's see what's up in here. Increase upgrade limit to 512. Okay. The change increases the upgrade limit from blah blah blah. Yeah, we've already read that. Will fail compilation and debug configurations. It pays for function either return or pass. Blah, blah. I did prompt. I did ask Chippy about this previously, and it claimed. I did ask Chippy about this previously, and it claimed that the copy is perfectly fine and fast. For now, I would not change this unless you measure this and tell if it is really faster. 64 bytes copy is perfectly. Can tell that it is both changing, returning values by reference. Also adds a new level of complexity. Actually adds Add function for outputting debug data. Num chunks, num bits. 16 hex digits. Okay. Okay, I would like to make a test. Godbolt. Godbolt. Void main. Well, void main is not really correct. Int main. Return 0. So let me ask ChatGPT. Can you generate me some C++ test code that simply does a bunch of copies? That simply, can you generate me some C++ test code with a main function and 2 test functions, where one of them tests the performance for a 64 bytes struct passing to function by reference, and then another function, and the other function tests the performance for a 64 bytes struct passing to function by value. Put them into larger loops so that they repeats many times for the measurements. Log print the measurement results in printf function with printf function. Yeah. Let's see what he comes up with. Self-contained, chrono, blah blah, line s, test struct, data, 64 bytes, okay. Ref. Pass by reference, iterations, test struct, process by ref. Okay, let's just copy this. It says disabling inline to ensure real call overhead is measured. Use release mode so the results will be meaningless. Okay. Okay, it sounds pretty good. Okay, let's copy this in here. Okay, pass by reference. So on GCC it was the same. Pretty much. But here it took longer, and here it failed. Didn't print anything. Why not? Program return. Okay, I don't know what's going on. I would like to see this in MSVC. Let's try x64 MSVC. Okay, that has worked. Okay, so by value it took much longer. X64. Okay. Okay. Okay, I think all of these are 64-bit, essentially. But it's fine. It's fine. Okay, so to me it looks like by reference much faster. Yeah. Prevent inlining and over-optimization. Okay. NS. Can we do milliseconds maybe? Because it seems a bit excessive here. Nanoseconds. Let's do milliseconds. Okay, it still says NS here. Let's change that to MS. Okay, so interestingly here on GCC, passing by reference and value is pretty much identical. On MSVC as well. But on Clang, pass by reference is much faster than this other one. Why is that? This is so much slower. That looks suspicious. Why is that? Pass by reference. That's interesting. Pass by reference. It's so much slower. Pass by value. It's actually surprising that it is M32. Clang minus M32. Is that for the architecture? What is the minus M32 compiler flag do? 32-bit code. Aha. Can we? How do we tell? x64 MSVC compiler to generate x86 code, if possible? You do not use a flag toolset. Okay. Okay, so it's different compiler. Let's try again. Let's change it to x86 MSVC latest. That doesn't work somehow. Let's try another one, like this one. Doesn't work. Let's try an older one. Well, there's none. Well, let's stick with x64 and just assume it is representative. Yeah. Okay, so this guy here, so that's interesting. What happens if we remove this? That's about the same, a little bit faster here. M32. Yeah, it's so much slower. Why is that? Fast by ref, process by value. Interesting. Clock. Test pass by value. Start end. That's data. Process by value. Yeah, okay. I don't know why Clang is so much slower. It really is suspicious. It is interesting that MSVC is actually the fastest here, but maybe that's because it is 64-bit. Yeah. So if we made it fair and we made all of them 64, then what happens? Still, what? Oh, there's an error. Huh. Oh, the ABI for passing parameters with 64 byte alignment has changed. Okay, so the alignment is not good. Let's comment out the alignment here. Okay, that compiles. Okay, so pass by value now is here faster on MSVC, but it's so much slower on Clang. That's insane. That's absolutely insane. Interesting. Good, then what I will do... let me actually ask on with the Clang compiler, the copy by value is magnitudes. Is how much? Like 10 times or so, right? Where is it? Yeah, it's like, yeah, 10 times. It's about 10 times. It's about 10 times slower. With a Clang compiler, the copy by value is about 10 times slower than copy by reference, pass by reference. Pass by reference. Pass by value is about 10 times slower than pass by reference. Whereas on GCC and MSVC, it is about identical. It's about same speed. Why? Tell me. A real and well-known effect, and it comes down to RBE rules. Optimizer behavior, not Clang being slow. Short version than the deep dive shown on Clang is obeying the ABI more literally and ends up copying the 64-byte struct on every call, while GCC and MSVC are able to avoid or elide the copy in your benchmark. Pass by value, real memory copy. Pass by reference, no copy. 10x difference. Effectively the same code, similar speed. ABI rules for large structs. Structs larger than 16 bytes are not passed in registers, passed via memory. Caller allocates temporary and copies into it. Oof. This copy is mandated by the ABI. Very conservative is by value ABI semantics. Big slowdown. Okay, how about we test without the no inline? So we take this guy and we do a define no inline. Let's do undef define no inline. Interesting. Now with no inline, its Clang is faster. So if it can use inlining. Interesting. Okay. Good. Let's keep it with this test here. Okay. I think that is conclusive enough. Let me copy that over. I asked GP to generate test codes for this. I can just share other share short link. And copied that to Godbolt. Results. So GCC Clang MSVC. So 64 bits MSVC 02, 64 bits Clang -03, and 64 bits GCC 03. Code, test codes. Conclusion: given Clang is showing weakness here, pass by reference looks preferable. Tested with 64-bit compilers because 32 bits MSVC gives no output. Output in Godbolt. Okay. Good. Then yeah, let's stick to pass by reference. Then that's okay. Otherwise, pass by value looks like it would have been okay, I guess. Okay, let's see what the change says now. So bit flags, upgrade. Increases max upgrade count from 64 to allow for more upgrades. The value of 512 should allow room for plenty of upgrades while also conserving memory. Fair enough. Okay, cool. Upgrade mask type. Canvas, yes. X for user. X for upgrade mask. Mask. Test for great name. Write out the upgrades as strings. Oh, the serialization works with strings. Oof. Aha. Aha, okay. Aha. Okay. Okay, I see it operates. It operates on strings, so it looks okay. But what about this guy? It looks like it will infer data size, data. Yeah. Actually, do a delete. Do this comment. X user. To hex string .cstr. to hex string. Oh boy, why is this so complicated? Oof. Chunk boof. Concats. Chunks. Oof. For outputting debug data. Does ASCII string have a reserve function? ASCII string reserve. It doesn't. Oh. Mm-hmm. Okay. So num bits plus 63, so it clamps it. Okay. Num chunks. Consts, expr consts. Check. Printed any. Printed any. Should start from the end. Oof. Test chunk. Okay, so it starts with the last chunk and then moves down. Is that correct? I guess so. No. Okay, it makes sense, yeah. If chunk is 0. Oh, okay, it's quite a bit complicated logic, but it seems reasonable. A bit is smaller than 64. Bit. about this one here. Regarding given the following code, is there how do we call it? Is there a way to write this for both? Write this without compiler variations. I guess we could have like 1 and then we cast it to an integer. Yeah, I don't think we have to do this here. So we could have like val or and then like a int 1 and then shift it, I think. So if we go to our types, base type, we have, oh boy, base type core, this one. Can merge this as val one bit. Val. What is val? Huh? Ah, here, unsigned long. Mm-hmm. 64. Well, this one takes ll printf. LL. Oh, where's the L here? Here, LL long, unsigned long. Okay, then maybe unsigned long is better. Then let's say unsigned long. One. Okay, and yeah, so basically he goes from the end and then he looks at all the chunks, the 64-bit chunks. He gets all the individual bits, queries it, and then dumps it into this intermediate buffer with the SN printf, and then concats it into the result. Yeah. Yeah. Looks correct to me, this implementation here. Okay, good. Then I think this is fine. He did add these tweaks here. To hex string. Okay. Perhaps move the imp to the CPP to keep. Can it be moved to Bitflex? Does it have a CPP? It's a template class, right? Never mind. The CPP is only for some things there. Okay. No, it's a template class, so the function has to be here in the header. Okay, no, I think that looks pretty good. Yeah. Yeah. Still looks correct to me. Yeah. Yeah. Okay, cool. Good, then this one is resolved. String. CSTR. Okay, let's put that review there. Good. Then I think I'm done with this review here. I still need a review for the particles, please. Oh, I don't know why I just clicked there now. Okay, let me see if there are any comments. Okay, what's the time? 1 hour 33. Okay. Good. So I don't know when review for this guy comes, but maybe in the meantime, what we do is smudge effect. Let's take a look at this one. There's another. If it's airborne, wait for it to land. Okay. Okay. That makes sense, yeah. Okay. Okay, and this other one, let me see. If our goal is contained by something else, give up. This is for the following bug. Tell some rangers to enter Humvee, tell the Humvee to enter Chinook, blah blah. Follow the Chinook like dopes. This just bails in this case. Okay, well then just leave it, I guess. Yes, vertical overlap. Okay. Good. I think this looks good. Yeah. Good. I didn't test it, but just judging by the codes, let's look again, just in case. So this one preserves the original behavior, else this, yeah, it's fine. What he could also do is I think it's fine. Okay. Okay, what about this guy? For 7+ months. When implementation. Core issue is clear. I guess there's no proper API for render target copies. Copyrights is designed for detect driver level SSAA. Stretch right. Memcopy is a good idea. Yeah. Mm-hmm. 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 Good. Then next I would like to fix camera constraints. Refactor default zoom init. That one's gone. So yeah, I think what we can already do is create a review for these here. These. Mm-hmm. Face type. Uh-huh. Mm-hmm. Yeah. Okay, let's do that next session. Do a review for these guys here. Mm-hmm. Okay. Then I will take a break now. Yeah. Then I wish you a great day or night. Until next time. Goodbye.